In the future, work environments will be designed to be occupied by both humans and machines. Even in today's most advanced work contexts, in government research labs or in the private sector, we don't have clear design or management, and as we saw today earlier, policy models for this future workspace. However, we do know that we're approaching a state where, as part of their everyday experience, workers are going to collaborate and will even share space with various forms of artificial intelligence. At the edges of the world of work, we can already see more integration between what's human work and what's machine work, be it invisible code bots or algorithms, or even autonomous robots with physical presence. Now, realistically, we're just at the beginning of understanding what this new work reality might represent. So today, I'm going to speak briefly about this future convergence. In my work, I research programmability and the effects of it in the built environment. It's not something we see typically in the everyday office, but I apply this to the design of future high-tech workspaces. I study lead technology users and their work habitats at the edge of the world of work, where programmability is a key design element. Environments like mission controls, co-working spaces, hacker spaces, robotics labs, submarines, the ISS. These are all examples of the habitats that I study and that I speak about. In this case, in this environment, technology is the fundamental design element. The work these people do is often complex, and these occupants could not perform, and in some cases like this, could not survive if technology were not part of the space. So these environments, these spaces, are clearly not your mainstream average office space, and these are not mainstream average workers. In fact, they're lead users in that they encounter and they become familiar with design conditions that average users, the rest of us, will only see in the future. What's important about this is that working in these habitats, these high performers adopt the speed and the sensibility of software. It's a sort of intuition that impacts their communication patterns. It impacts the way they collaborate, their expectations, their assumptions about work and performance. So it really informs the way they work with each other, they construct the knowledge, and they make decisions, which are basic work functions across any discipline. So in looking at the future of work, I believe that these lead users and these habitats are important analogs. They help us understand, they give us valuable insights into the design requirements of the future worker and the future workspace. My design peers sometimes ask me why I've chosen this line of work, and I can think of a number of reasons. One of which, however, is that I believe this is an emergent field, a complex one, actually, as we'll talk about and we've heard today, but with vast opportunity for competitive advantage. See, business leaders believe, and they often make considerable investment based on this, that a workspace, a future headquarters, a future corporate campus, can influence a company's trajectory, can inspire future leaders and generations of future leaders, and can transform culture. But as any CIO or real estate executive knows, the world of buildings and the world of software operate on entirely different timescales. One, software is optimized for speed and for upgrades. Buildings are optimized to stand the test of time, which in that case always means decades. So this presents a considerable challenge when you're actually building. So I'm going to share two insights that have worked, and I've consistently seen them in my work in creating high-tech future workspaces. The first one is the future workspaces will require interaction with digital information, i.e. data, to be spatial, well beyond the confines of your screen. Future employees are not going to be content with just getting a laptop or a tablet or a mobile device. They're going to gravitate towards companies whose workplaces provide new forms of interaction and data, new forms of collaboration as part of this physical space. These are examples from my work in a corporate lab at a technology company's headquarters, where building blocks of space, like walls or furniture, were seen as real estate for software interaction with the aim to increase productivity. The second insight that I see works is that future workers will organize through management models inspired by networks. Lead users today already organize themselves because of their interactions and the way they collaborate online as networks. This is how they collaborate. This is how they mobilize their resources. They do so to accelerate their knowledge and their learning. This logic, which is, for example, typical of co-working spaces, can be applied not just to workspace environments, but it can also be applied to the design of civic space. Here in these slides, I show the results of my work testing this hypothesis in a co-working experiment in downtown Las Vegas. We applied network logic to catalyze a co-working and startup community where it didn't exist before at the launch of the Downtown Project, which is a civic and revitalization initiative led by Zappo CEO Tony Hsieh in downtown. So in looking ahead, if we think of the digital transformation of work over the last 15 years, we can safely predict that there's just going to be a lot more complexity. And inevitably, the interaction between human work and machine work is going to be a crucial factor. To be successful, most future organizations will require teams extremely skilled at integrating machine assistance, at understanding, manipulating, and interpreting complex data systems independently of geographical location or time. To perform at their best, these future teams, more than any previous work generation, will need access to spaces that are specifically designed for sophisticated human-to-data, or human-to-machine, as we say, interactions. So as I mentioned earlier, the convergence of human work and machine work is a new work reality, certainly looking to the future. And obviously, it's a complex one. But when I studied those future teams today, and I study the way they work and collaborate, I recognize in the 10, 15-year-olds that I observe the emergence of a new kind of lead user. These are some images I'll show in a second from robotics competitions, which is a programmable habitat I've been researching for the last year. For these future workers, as any parent in the room might know, these folks find great meaning in tackling new challenges through objectively advanced programming, even by professional standards, not just of code, but also of robots. For them, it's not only a fun after-school program, but it's a way to learn with friends, to be creative, to innovate and come up with new solutions, to compete, and mostly to belong, as any teenager would like. To be part of a team, but in this case, these teams are made both with robotics and by robotics players as well as human players. So in conclusion, in looking forward, we see that many teenagers, and in some cases young children in America, thousands of them in fact, are growing up with the assumption that beyond smartphones, interacting with machines is sometimes machines that they build and they program themselves is just part of life. So it's going to be part of their future homes and their future workspaces. For them, programming is not just about code, it's about inhabiting the world that they will live in. So we are looking from the point of my work at an entirely new domain in the world of work and of workspace, one for which the textbook has absolutely not yet been written. So empowering these future workers to meet their potential and to innovate, and perhaps even with machines, in solving some of what we know will be complex problems tomorrow is actually the real reason I've chosen this line of work. And for me, it's been a very rewarding and continues to be a very rewarding and surprising journey. Thank you.